Okay, Assalamualaikum. Today we proceed with the cumulative distribution function CDF for continuous random variable. Okay, so in the previous lesson, you have learned I introduced you to the continuous the PDF for continuous random variable, and also how to find the probability using the integration. Okay, so as you know, untuk continuous, untuk dapatkan probability, sebelum ni I lupa nak highlight. Okay, in your textbook actually, you can turn to page 108. Okay. Okay, so this actually I have mentioned before this in the previous video, which is to find the probability for continuous random variable. Okay, if we want to find the probability of x more than a less than or equal to b, okay, this probability is equal with the probability of x more than a less than b. So maksudnya kat sini kalau ada tanda inequalitiesnya ada more than equal ataupun more than saja, less than equal ataupun less than saja, sama saja untuk continuous, sama dari segi to find the probability. Okay. Okay, so sama dekat sini. So actually kalau untuk discrete, it is x more than a less than b plus probability of x equal to b. Because of this here, dia punya inequalities is less than or equal. But untuk continuous, this probability sama je dengan x more than a less than b. Okay, which is you need to integrate lah from a to b untuk continuous. Okay, and then this is the penny graph. Okay, when the PDF for continuous is involved, okay, we have different types of graph. Inilah contoh-contohnya untuk continuous. Okay, kan sebelum ni dah tengok untuk discrete macam mana kita nak plot the graph, and untuk continuous it depends on the function to itself, whether function to quadratic ke straight line and so on. Okay, it depends. And then this is the illustration. Kalau let's say kita nak cari nilai probability, so dia punya value probability ni illustrationnya macam ni lah, because of we know that a valid function, okay, the probability of valid function fx, dia punya probability 1. Okay, dia nilai probability-nya 1. So dalam this distribution, 1 lah dia nilai probability. So untuk dapatkan probability of a probability of x from a to b, so its probability is between this area, this region will be the nilai of the probability. Okay, so let's see how to find the cumulative distribution of a continuous random variable with the density functions given if small fx. Okay, let's say we have the PDF. We have the function of fx. Now we want to find the CDF, cumulative distribution function. Okay, so dia punya konsep sama saja untuk cumulative dan discrete. Dia punya konsep sama sahaja, which is sekejap ya. Where is my okay, this is the concept to find the probability to find the cumulative distribution function CDF for discrete or continuous, kita gunakan konsep ni. Okay, which is the notation capital F. It is the probability of x less than or equal. Okay, kena ada less than or equal to some value of x. Tapi untuk continuous, less than sahaja pun, less than, equal and less than of x is equal saja. Cara nak cari nilai probability. Okay, so nak cari this probability untuk continuous, we need to integrate. We need to integrate the function of fx ataupun kita first you need to replace dulu x tadi dengan t. Okay. So gantikan bila kita dah ada fx, gantikan x here dengan t. Okay. So it will be integration of ft terhadap dt with respect to t from negative infinity until x. Sebab apa? Sebab less than or equal to x. Okay, sebab less than x, so daripada negative infinity ni depends pada kita punya region of the function of x. Okay, region of function for x. Kalau kat sini start dengan 0, you punya x, so di sini will start dengan 0. Kalau di sini you punya region start dengan negative 3, so here will be negative 3 until x. Sebab less than or equal to some value of x. Sehingga x, wajib sehingga x. Okay, so you akan dapat satu function. So untuk cumulative ni, untuk cumulative distribution function for continuous, you akan dapat satu function juga. Maksudnya, kalau you punya variable x, you punya fx in terms of x, you punya capital fx pun akan ada in terms of x juga. Okay, sebab kita integrate daripada negative infinity sehingga x. Okay, let's see this example from the previous example actually. For the density function of example 3.1, okay, find the CDF. Okay, so from the previous, this is the function which is x square over 3. Dia punya region negative 1 sehingga 2. So nak dapatkan value of nak dapatkan function of capital X, which is the cumulative distribution function CDF. So what you need to do is you need to find the probability of x less than or equal to some value of x, which is kita kena integrate kan. Untuk dapatkan probability untuk continuous kena integrate. Integrate function mana? Kata tadi function ft. So ini function fx. So kena tukar dulu fx tu kepada ft, which is dia akan jadi t square over 3. Okay, t square over 3. So here, you akan integrate function of t square over 3 terhadap dt. Okay, terhadap dt. Sebab kat sini kita dah tukar kepada t. Okay, from where to where? Start daripada mana ke mana? Less than or equal to x. So, start daripada mana? Start daripada negative 1. It depends pada you punya interval. Okay, kena tengok. Check you punya interval for the random variable. Sehingga x. Because of less than or equal to x ke bawah, x daripada negatif 1 sehingga x, dan integrate macam biasa. Okay, bila you integrate dia akan dapatlah yang ni tadi. Okay, integrate from negative 1 until x. Integrate t square over 3 with respect to t. So you will get t power of 3 divide dengan 3 multiply 3 tadi kan, akan dapat 9 from negative 1 and x. And then macam biasalah, first you kena replace the t here with x, and then minus dengan replace pula negative 1 t here with negative 1. So let's see, kalau you buat 1 by 1, so you will get x power of 3 over 9 minus negative 1 over 9. Because of that, you akan dapat x power of 3 plus 1 over 9. So this is your CDF. This is your CDF. Okay. So how to express your CDF function will be like this. Okay. Kalau less than negative 1, kenapa kita ambil negative 1? Sebab tadi kan functionnya, dia punya interval for x tadi daripada negative 1. So less than negative 1 is 0. The CDF for the interval x from negative 1 until 2 is this, which is kita cari tadi. And then if more than 2, this value interval tadi, apa limit dia? So dia punya nilai probability will be 1. Okay. Selepas daripada tu pun dia punya nilai probability will be 1. Maksudnya kalau punya x tu adalah 3 ke 4 ke, so nilai dia punya CDF will be 1. Okay. Ini yang saya cakap tadi. Untuk dapatkan CDF function, you akan dapat in terms of x juga. Okay. You akan dapat in terms of x. Okay. That is the way how to find the CDF function. Okay, and then from the CDF function juga, we can find the uh, probability. Kita boleh cari nilai probability daripada CDF. Means that bila kita ada CDF function, we can find the probability of X. Macam sebelum ni pun untuk discrete kan, bila kita ada CDF, kita boleh cari nilai probability gunakan capital F. Okay, so untuk continuous, untuk cari probability of X from A to B, so it will be just FB minus FA. Which mean macam mana nak cari FA? FB dan FA ni, which mean we just you replacekan B and A dalam function capital F. Okay, so kalau B dan A ni adalah unknown lah, 3 ke 2 kan. So just gantikan dalam kat sini, dalam function ni. Okay, so let's say kalau soalan nak dapatkan probability of probability of X from A to less than or equal to B, so sama juga, it will be FB minus FA because this is the continuous random variable. Okay, let's see this. The cumulative, okay, dia kata kat sini, find and use the capital Fx to evaluate probability of X from 0 more than 0, probability of X more than 0, less than or equal to 1. So we just find it using the value of F1 minus F0, capital F1 minus capital F0. How to find this? Just replacekan, untuk dapatkan F1, replace 1 in this function, which is our capital Fx. So, untuk replace kat sini, you akan dapat replace 1 in X here, you akan dapat 1 plus 1 over 9 minus, sebab tu akan dapat 2 over 9 here, minus, and then replace pula 0, replace X with 0 untuk dapatkan F0. So you will get 1 over 9. Because of that, we get 2 over 9 minus 1 over 9. The answer will be 1 over 9. So means that here, if we have the CDF function, we also can find the probability using the CDF function. Can find the probability of X. Okay, let's say pula. Let's say nak cari nilai probability of X more than 1 contohnya. Okay, how to using the CDF, how to find this? Okay, make sure kan kalau CDF nilai value function fx ni adalah less than or equal to x kan, less than or equal to x. So you kena tukar dulu this one ke dalam bentuk less than or equal to, which is okay, it will be 1 minus probability of x less than or equal to 1. Is it true? Kan? Will be 1 minus less than or equal to 1. So this is 1 minus 1 minus F1, right? 1 minus F1. So it's just 1 minus, then F1, how to get this? Replace dalam function ini, which is 2 over 9. So you akan dapat 7 over 9. Okay, let's say soalan nak cari probability of X less than or equal to 0.5 contohnya. So what to do? Just, sebab di sini dah less than or equal, so boleh terus guna capital F 0.5. Just replace X here with 0.5. Okay, that is the way how you find the probability using the CDF. Okay, let's see the other example. Okay, if we have two interval here, okay, fx, okay, we have random variable x, which is x adalah continuous random variable, and we have two interval here, x from 0 to 1 and x from -1 until 2. We have two function. So sebelum ni m here is 2. So just kita gunakan yang ni, dah tunjuk in the previous lesson sebelum ni, dah tunjuk contoh macam mana nak dapatkan nilai M dan juga macam mana nak cari B ni kan. So sekarang kita nak cari cumulative distribution of X if we have two interval here and we have two function of fx here. So what to do is, kena cari fx for uh, for both of the interval here. Okay, untuk yang pertama. Okay, untuk yang pertama, it will be, we know that to find the capital Fx, it is x less than or equal to some value of x. So, we just simply integrate ft, which is t, kan? So, ft untuk yang ni, for interval pertama ni, ft-nya adalah t, right? We replace x with t. So we integrate function t with respect to t from 0 until x. Okay, sebab kita nak less than or equal to x. So from 0 until x. Itu untuk interval yang pertama. Okay, so here, okay, so you integrate t with respect to t, you akan dapat t square over 2. Okay, you akan dapat t square over 2. Okay, then replace with x and 0, then minus that value. So, you akan dapat x square over 2 minus 0. So, this is your fx, capital Fx untuk interval yang pertama. Okay, kena buat juga untuk interval yang kedua, which is interval 1 until 2. So it will be okay. So nak dapatkan capital Fx, kita guna konsep yang sama. It is probability of x less than or equal to some value of x. Tapi kita nak gunakan untuk yang kedua. Kita tahu Fx ni adalah kumulatif, terkumpul. So dia kena start dengan yang mula-mula dulu. So because of that, kalau kita ada dua interval macam ni, nak cari Fx for the second interval, it will be we integrate the first function with respect to t from 0 to 1. Kita ambil 0 to 1. But untuk yang kedua tu yang kita nak cari interval untuk 1 to 2. So it will be from 1 until x. And then the function will be 2 minus t dt. Okay. Kenapa? Because of Fx ni adalah kumulatif. Bila kumulatif, you kena ambil start daripada awal. Untuk kita cari cumulative distribution for the second interval. Okay, so remember that. Jangan you simply ambil bahagian ini sahaja. Kena ambil untuk kesemua. Tapi the first one will be you integrate from 0 to 1. Okay. Okay, this is the way how you do it tadi. So untuk dapatkan this capital Fx for the second interval. So you integrate t from 0 to 1 and then integrate 2 minus t from 1 until x, then integrate macam biasa. You akan dapat for the first one t square over 2 1 to 0. Okay, so for and then plus, keep plus, integrate of 2x, tadi 2 minus t, so akan dapat 2t minus t square over 2, and then you need to replace with x and 1. So kat sini t square over 2 gantikan t with 1, so you akan dapat 1 over 2, and then minus dengan 0. Untuk yang ni you akan dapat 1 over 2 minus 0 kat sini. Okay, this one lah. You akan dapat 1 over 2. And then plus here, plus, replace pula this 2t with x. So we'll get 2x minus x square over 2. Okay, and then minus dengan okay, will be minus with replace pula 1 here. You will get 2. How to get 3 over 2 here? So you akan dapat 2 minus 1 over 2, right? So you will get 3 over 2 here. Okay, so this is the function that you will get untuk second interval. So you can write down like this. Ataupun boleh tambah lagi ke atas ni pun boleh. Okay, I erase this one. So it should be here, if x less than or equal to 0, so the CDF will be 0. And if x more than or equal to 2, the CDF will be 1. Okay, that is the way how you find the probability. To find the CDF function for continuous random variable. Okay, so I nak tunjuk contoh satu. Okay, ini CDF yang you ada. Let's say you nak cari nilai probability. Tadi kan kita nak cari nilai probability of x contohnya from let's see 0.1 until 0.8 contohnya. So it just f 0.8 minus f 0.1. How to get these two value? Just replace dalam CDF yang pertama because of 0.8 and 0.1 ni berada dalam first interval. Okay, let's say kalau you nak cari probability of x from 0.8 until 1.5 contohnya. So what you need to do is f 1.5 minus f 0.8, right? So how to find f 1.5? Okay, you need to use the second CDF here sebab 1.5 berada dalam second interval. Okay. Okay, f 0.8 ambil daripada use the first CDF because of 0.8 berada dalam first interval. Okay. Alright. So di sini pula I nak highlightkan if we have CDF, we want to find the PDF. Okay, daripada PDF, kita ada PDF, nak cari CDF, you kena integrate. Tapi bila dah ada CDF function, you nak tukar kepada PDF which is small fx, daripada capital F nak tukar kepada small fx, you need to differentiate. Okay, which is this. You differentiatekan capital F, you akan dapat small f. Okay, let's see this one kan. Tadi, kita punya CDF. You differentiatekan this CDF. I padam dulu all these things. Okay. This is our capital Fx. Untuk dapatkan small fx, you need to differentiatekan the capital Fx, which is kena differentiatekan x power of 3 over 9, okay, x power of 3 plus 1 over 9 terhadap dx. Okay, bila differentiatekan x power of 3, you akan dapat 3x square, right? Plus 0, kan? Divide by 9. So from there, you akan dapat x square over 3. Sorry. X square over 3, which is the function of fx ni tadi. Is function x square over 3. Dapat balik small fx. So that is the way how to find the PDF if we have CDF. Right? Okay, that's all. And then this is the graph for continuous cumulative distribution function. It is like or GIF. Okay, it will be like that. Okay, so that's it for now.